straight line part 2, slope of a line. We were doing the slope of a line, so we'll continue slope of a line. If we have, this is x-axis and y-axis, and there is a line which is making an angle of theta with the positive direction of x-axis. The x-axis, this is y-axis and x dash. Then this line is making an angle of theta with the positive direction of x-axis, anti-clockwise positive direction, and this angle will be 180 minus theta. So that's why this right side angle we will take 180 minus theta. So this is the angle of inclination, and the slope of a line will be the tangent of the angle of the inclination, that is tan theta. Tan theta is called the slope of a line. Slope of a line is denoted by tan theta. We can find out by tan theta, and it is denoted by m. Slope of a line is denoted by m. M is called the slope of a line. M is also called gradient of a line also. So gradient, either we say gradient or slope, one and the same thing. Slope means how much angle it is making, tangent of the angle which the line makes with the x-axis in the positive direction. How to find the slope now? This is the slope which we can find out when the angle is given. When theta is given, theta should not be equal to 90 degree, because when it is 90 degree, there will be infinite slope. Tan 90 is infinity, because when theta is equal to 90 degree, tan 90 degree will be equal to infinity, means infinite slope. The slope will be infinite, that means a straight line. Straight line means the slope is infinite. If the line is like this, then its slope is infinite. Its slope is infinite. So that means it is not, we cannot represent this slope. This is 90 degree infinite slope. So it should make some angle in the positive direction of x-axis. Second thing, if the points are given, suppose we have given, this is coordinate geometry, we are doing the coordinate geometry. So P, suppose P is a point on this line whose coordinates are given as x1, y1, and Q is another point whose coordinates are x2 and y2. Then how to find the slope of a line when coordinates of any 2 points, slope of a line when coordinates, when 2 points are given on the, when 2 points means coordinates of points, when 2 points are given on the line, the 2 points are given, how to find the slope? So in this case, slope m we are denoting by m, or we can say tan theta will be equal to y2 minus y1, y2 minus y1 divided by over x2 minus x1, x2 minus x1. So when 2 coordinates are given, we can find the slope by using this formula. Now how to find the angle? Tan theta is the angle between the 2 lines. Now how to find the angle between 2 lines? If 2 lines are having the different slopes, angle between 2 lines, angle between two lines. That is acute angle. We are finding the acute angle because whenever you have given the 2 lines, suppose this is a line and another line is this one. So they can have two types of angles between them. One angle is this is less than 90 degree theta, and this is acute angle. So we are finding acute angle by this formula. So how we'll find, if the gradients of the lines are given, means slope, suppose the slope of line M first is M1 and slope of the line M, suppose say this is line AB, slope of line AB is M1 and CD, slope of line CD is M2. Then we can find the angle between them by using the formula tan theta is equal to absolute value of M2 minus M1 upon 1 plus M1 M2. By using this formula, we can find the slope. Subjected to the condition 1 plus M1 M2 should not be equal to 0, otherwise it will become infinity. What will happen if the lines are perpendicular to each other? If the lines are perpendicular to each other, suppose we have two lines here. One line is this one, another is perpendicular to this line, and then what will be the angle between them? You know that angle will be 90 degree. This will be 90 degree. Angle between them will be 90 degree. Okay. So this is suppose L1 line and L2 line. When they are perpendicular, M1 into M2, its slope is M1 and its slope is M2. So if you will put 90 degree in this formula, M2 minus M1 upon 1 plus M1 M2 is equal to 90 degree. Tan 90 degree is equal to infinity. Infinity is equal to 1 by 0. Tan 90 is infinity, and infinity means 1 divided by 0 is infinity. So 0 will be multiplied here and it will go there. So the left side will become 0 and 1 plus M1 and M2 will multiply with 1. So right side we will get 1 plus M1 M2. And 1 we can take left side. So we got M1 into M2 condition is equal to minus 1. So slope of the two lines which are perpendicular to each other, their product is equal to always minus 1. So this is our condition for the perpendicularity. So two lines, if we have to prove the two lines are perpendicular, or if two lines are given perpendicular, so we can use this formula. This is the perpendicularity of the two lines. But if the two lines are parallel to each other, what will happen if they are parallel to each other? Suppose this line is parallel to this line, and their slopes are M1, M2. M1 is the slope of this line and M2 is the slope of this line. Then what is the angle between them? No angle. They have 0 angle. So we can put in this formula M1 minus M2 upon 1 plus M1 M2. 1 plus M1 M2 is equal to tan 0 degree. Tan 0 degree is 0. Tan 0 degree is 0. So in this case, this denominator will become 0. We get M2 minus m1 is equal to 0, so m2 is equal to m1. So we can say m1 is equal to m2 or m2 is equal to m1. So this is the condition of parallel lines. So that means parallel lines will have the same slope. Obviously, if this is a parallel line, if I want to draw another parallel line of this if I want to draw another parallel line which is parallel to this line, suppose, so this will make equal angle or not? Same angle. It will make theta angle. This is theta, so this will be also theta. So that means they have inclined with the same angle. So parallel lines will incline with the same angle with the x-axis. That's why their gradient are equal. So for parallel lines, so now we got the fourth condition. Parallel lines, or first you can write perpendicular line, no problem. Parallel lines m1 is equal to m2. Gradients are equal for perpendicular lines. For perpendicular lines, m1 into m2 is equal to -1. Okay. How we will show that the points are collinear? How we show that the points lie on the same line? By using the gradient formula. So condition of parallelism and perpendicularity of the two lines we have seen, angle between the two lines. Now this is you can see here also one more thing, that if this side is positive, if tan theta is coming positive, if you will remove this absolute value, so you can get plus and minus, or I think we'll write don't get confused. Now see this, if tan theta, you are finding tan theta m2 minus m1 without using the absolute value. So it can have minus and plus. It can give the value of minus and plus. So if it is equal to the positive value, if you are getting positive value, then this theta will be acute angle. Theta will be what? Acute angle. And if it is negative, tan theta you are getting negative, tan theta is negative, then theta will be obtuse. This angle will be obtuse angle. Obtuse angle. So it depends on the value. So without using this absolute value, you find the value and then you can remove this one, no? And then after that, check positive or negative. If positive means this angle, you are getting acute angle. And if it is negative, you are getting this angle. This is alpha. You can say this will be the obtuse angle. So lines are making between them one acute angle, one obtuse angle. So the question arises when we are going to find out the which angle we are getting. So this depends on the value of tan theta. If tan theta is coming positive, means the angle that you get is equal to acute angle. If tan theta is negative, you are getting obtuse angle. Okay, got it? Now in the starting 10th exercise number 10.1, in 10.1, so we have given draw a quadrilateral whose vertices are minus 4, 5, 0, 7, 5 minus 5, minus 4, minus 2. So this is our x-axis, and y-axis. So that you have to just plot the points a minus 4, 5, b 0, 7, c 5 minus 5, d. Now find its area. So how to find its area? We can divide into two triangles and we can find the area of these two triangles. So in this case, we can divide it into two triangles and then we can find the area. This is divide and add the areas of these two triangles, and area of triangle formula that we use in class 10th. So area of this area of triangle, we will find that separately and then add them to get the area of the quadrilateral. Area of triangle ABC, this triangle ABC. So the formula is ABC means this is A. We will take this A as x1, y1, as you have done in class 10th, x1, y1, x2, y2, x3, y3. So our formula is 1 by 2 x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Now just substitute the values. 1 by 2, what is x1? Here x1 is minus 4 into y2 is 7 minus y3 is minus 5, so minus plus 5 plus x2, where is x2? x2 is 0, so no need to put anything because it will become 0, plus x3 is 5, y1 minus y2, y1 is 5 minus y2 is 7, 5 minus 7. So 1 by 2, 7 plus 5, 12. 12 for the 48. And 5 minus 7 minus 2, so minus 10. Minus 48 minus 10, it will be equal to minus 58 by 2, and minus 58 divided by 2 and modulus. You know that area cannot be negative, so this will be 29 square units. 29 square units. Similarly, you will find the area of triangle. Another triangle is, which one triangle is ADC triangle. Its area will be, I am just writing, you can do it the same way, 63 by 2 square units. Then add them to get the area of, we have to find the area of quadrilateral ABCD is equal to the sum of the areas of these two triangles. So you can write 29 plus 63 by 2 and 58 plus 63 by 2 will be equal to 121 by 2 square units. Question number 2. The base of an equilateral triangle with side 2A lies along the y-axis. This base lies along the y-axis and the midpoint of the base is at origin. So that means this is the midpoint, this side and this will be same. These two will be same, and the each side, it is given that each side of the equilateral triangle is 2a. So this is also 2a, this is also 2a, but this is divided into two parts. So this is a and this is also a. Find the vertices of the triangle ABC. So obviously on B, the distance is a. On what will be the vertices of B? B is on y-axis. So y-axis means x coordinate will be 0 and distance on y-axis is a. So 0a. So vertex of B is 0a. C vertex, similarly C vertex will be 0 minus a. So B is what? 0a and C will be equal to 0 minus a, because on x y coordinate x axis on y axis the x coordinate is 0. Now we have to find this distance so that we can find the coordinates of a. We need to find this distance. Let us take as x. So by Pythagoras theorem we can find out this distance. So in triangle, in right triangle AOB by Pythagoras theorem, hypotenuse, the side which is opposite to 90 degrees is always hypotenuse. So this is the hypotenuse. So 2a square will be equal to a square plus x square. So 2a square means 4a square. 4a square minus a square is equal to x square. Lokesh, if you are present, tell your parents to call me today. 3a square. So x is equal to root 3a. X is equal to root 3a. So this distance we got root 3a. So on x-axis, the coordinates will be root 3a and 0. Oh, nothing, I have to talk. Nothing happened. Yes, I want to talk on some important matter. Okay, so A, but in the question they have given that the midpoint of the base is at origin. So this triangle can be on the left side because they have not said that it is on the right side. So it can be from this side also, it can have this side also. So when this triangle is, we will consider this one also. When this triangle is on this side, then the length of, because this will be the same length, so this coordinate, suppose this is coordinate a dash vertex, its coordinate will be minus root 3a and 0. So this is also possible. So we have to write that the vertices of the triangle, either hence, or answer will be hence vertices of a triangle are root 3a 0 a, yes, wait, okay, 0 minus a, or minus root 3a 0 a and 0 minus A.